Alright, this is picking up where we left off yesterday, and you'll start with a practice. Add or subtract, write your answer in standard form. Add those two quantities together. First up, you're going to have to understand that it's addition, so there are no signs to change. You just have to add like terms. Negative 36x squared plus 6x squared is negative 30x squared. You have a 6x, and there are no other x terms to add it with. You have negative 11 plus negative 5. It's minus 16. And then you have a plus 16x to the third. Go back and double check, make sure everything's been taken care of. You have your x to the third term here. It was by itself. You had a pair of x squares that we put here. We had an x term there, and then our constants here and here. We combined them there. Problem says put the answer in standard form, so that means 16x to the third minus 30x squared plus 6x minus 16, descending powers of x. Add or subtract, write your answer in standard form. This one is subtraction. This one is subtraction, which means you're going to leave the first term the same, 5x cubed plus 12 plus 6x squared, and then change the sign of everything in the second quantity because of this. Minus 15x squared minus 3x plus 2. And then add like terms. You have a 5x to the third, but nothing else to add it with. Your next power down of x is squared. 6x squared minus 15x squared is minus 9x squared. We just have a minus 3x for the x terms, and then a 12 plus 2 is 14. Here's an example. The cardiac output is the amount of blood pumped through the heart. The output is measured by a technique called dye dilution. A doctor injects dye into the vein near the heart and measures the amount of dye in the arteries over time. The cardiac output of a particular patient can be approximated by the function f of t equals 0.0056 t to the third minus 0.22 t squared plus 2.33 t, where t represents time in seconds after the injection, where it's between 0 and 23, and f of t represents the concentration of dye in milligrams per liter. So in A, here's what has happened. You evaluate f of t for 0, and then you evaluate it for t equals 3. And in each case, when you do it for 0, it comes out to be 0, and if you put in 3 into the function, it comes back as 5.1612. So describe what the values of the injection, or not the injection, but the values of the function from part A represent. So f of 0 represents the concentration of dye in the artery at the start of the dye dilution process. And f of 3 represents the concentration of dye, 5.1612 milligrams per liter in the artery after 3 seconds. So there's the difference in between the two. This represents what it was at the start, and after 3 seconds, this is what it is, milligrams per liter, just from using that function. For a different patient, the dye dilution can be modeled by the function f of t equals 0.000468 x to the fourth minus 0.016 x to the third plus 0.095 x squared plus 0.806 x. Evaluate f of t for t equals 4 and t equals 17 and describe what the values of the function represent. When you do f of 4, you should come back with 3.839808. Alright, if you put in f of 17, you'll come back with 1.636828. Describe what the values of the function represent. This represents the concentration of dye in the arteries at 4 seconds in. This one represents the same thing, except it is going to be 17 seconds into the process. Graph each polynomial function on a calculator, describe the graph, and identify the number of real zeros. So you can graph this one on your calculator. Just go to y equals and clear out anything that's in there. I'm doing it on the screen in the back if you have any questions about what I'm doing. Go to y equals, clear out anything you have in there. And then into y1 you can put x to the third power and then minus x, just as it appears on the screen. If you hit zoom 9, it will create the graph for you. If you want to zoom in on the graph, which we're going to need to do in this case, you can hit zoom. There's the zoom menu on the screen, and then choose to zoom in. There should be a cursor that's floating around. You can see the cross that's out there in the screen, and I want to put that cross right in the middle of the graph, just down in the origin. So place it there and hit enter, and then look what happens. This part of the graph is magnified, and you're going to need that to answer these questions. So once again, the question is, graph each polynomial function on a calculator, describe the graph, and identify the number of real zeros. The number of real zeros of a graph comes from where it crosses the x-axis. How many times does it cross the x-axis? Well, on the one on the screen here, we have 1, and then we have 2, and then we have 3. It's good to know how to zoom in on these, because if it gets too bunched in, you can't really tell. On the screen in the back, that's why I showed you how to zoom it in. To describe the graph, from left to right, the graph increases, decreases slightly, and then increases again. It crosses the x-axis 3 times, so there appear to be 3 real zeros. That is the description of the graph. You go from left to right. Here it is from left to right. From left to right, the graph is increasing here, then it decreases again slightly, and then it's increasing after that point, just as it appears here. Graph each polynomial function on a calculator, describe the graph, and identify the number of real zeros. So it's 3x cubed plus 2x plus 1, and when you graph that on the calculator, it'll look just like this. This one isn't too difficult to figure out in terms of where it crosses the x-axis and how many times. So there's no need to put that in on your calculator and graph it right now. But you can do the description. From left to right, the graph increases. It does not decrease. And it crosses the x-axis once, right there. So there appears to be 1 real zero. X to the 4th plus x to the 3rd minus x squared plus 2x minus 3. From left to right, going this way, the graph decreases and then it increases. It crosses the x-axis twice, so there appears to be 2 real zeros. Graph each polynomial on a calculator, describe the graph, and identify the number of real zeros. The one you're going to do is this one, 5c. On your calculator, you should have come up with a graph that looks similar to this. and notice that it crosses the x-axis in two places, so you have two real zeros. And from left to right, it decreases, then it increases. So the answer is, from left to right, it decreases, then it increases, and it appears to cross the x-axis in two places, so it has two zeros.